Yeah, yeah, it'll be the same thing. We do that every year.
Like next year, we can't leave early unless we're taking college.
This will not change. This will not change. What? Right now. For some reason, it doesn't say recording started anymore. All right, so Ish had a question on this. I said, hold your question because today we're going to do a repeat, except we're going to do the big picture today.
Well, no. The one you gave us for yesterday, the chapter.
Oh, yeah.
We'll be fine.
There were some
Which
hard
one?
ones on.
Like one of these, because it was confusing, like why are the fractions? Like,
Well,
what's,
you still need to have a 4. So the only way you get a 4 is you divide out a 4. So, for instance, read that one.
1/4 y equals x squared.
Well, we got our x squared, but we know it's supposed to look like x squared is equal to either +4 or -4 times another number. So you would have had no problem if I had made this an 8, correct?
Yes.
You just divide by 4 and that would turn it 2. It's just a number. You'd still do the same process. If this had been an 8 instead of a 1/4, what would you do? By 4. You're going to do the same thing. So I'm going to take 1/4 and I'm going to divide by 4. Dividing by 4 is the same as multiplying by 1/4. So that's 1/16. So this is 1/16 y. There your.
You should add that into the lesson. Because that was.
I did. I said you divide by 4. All right. We will see that again when we do the chapter review. We will do something similar to it today, although I'm not doing parabolas, I'm doing ellipses today. But it applies to the ellipse when it does the parabola. Okay. Why are you not clicking?
Buy you a box of clickers when I graduate.
Oh, there it goes. All right, so we'll do 10.5 today. You get the complete total picture. We have one more lesson. This one's a little bit challenging as well, too, and then we're at the end of the test. Hey, okay, I got a mixture of juniors and seniors. All right, everyone on that Monday, you're going to
Be at home.
be at home doing e-learning. If you are a 10th grader, you're going to
Be here.
do we have any 10th graders here?
No.
No, so you will be doing e-learning, everyone here. Everyone on Wednesday will be doing e-learning. If you are a 11th grader, you're at school. If you're a 10th grader, or senior, you're going to be at home. Last, it's 7:40 to 11:30, something like that. Right, so it'll be lunchtime, you're gonna be going home. And then lastly, if you are a 11th grader or a 10th grader, I say 10th grade because I got a class with some 10th graders as well too. And seniors, I am not going to give you anything. This should have been your senior skip day. I have no idea why they didn't make this your senior skip day.
Wait, ours is on Friday?
Oh dear Lord, are you going to listen?
Oh, whoa!
I start off by saying seniors aren't coming to school the entire week.
Yeah, so why would that be our senior skip day if we're not?
Because I'm going to give you, all of your other teachers are going to give you work for that Friday.
That's it.
On senior skip day, what's going to happen in this class? On senior skip day, what's going to happen? I'm still going to teach a class and you're still going to be responsible for it. So wouldn't it have been smarter to do senior skip day on a day where no teacher's going to give you work?
Actually, but it's smarter to have it on a Monday because it's a longer day.
I could live with that. Right?
It is on Monday.
Yeah, but it should have been either this Monday or this Friday.
Okay.
When is it?
I don't know, 25th or something, 11th? Okay. All right.
11.1.
But guess what? I'm going to do 11.1 and you're responsible for it.
Yeah, is it gonna be hard?
That's part of the charm, having to catch up.
Oh, it's part of the charm. That's the feature of it?
Yeah.
Okay.
We probably won't do it.
I would probably.
All right.
have
3
to record
questions.
this class.
All right, homework tonight, and as you immediately notice,
A-D?
it's not A through D. They're not word problems.
Steps.
There are many multiple steps. We will do 2 of these today in class because it takes me the entire class to do 2 problems.
Hard.
It is not hard.
If it wasn't hard, then it wouldn't be so long.
So it's just a long process.
How hard is it to turn 18?
Super hard.
It takes 18 years, so it just takes a long time. But how hard is it to turn 18? Well, everybody just kind of turns 18 with or without any effort.
You die.
Thank
That's a
you,
good point.
Captain Negative.
That's a good point.
It's hard staying alive for 18 years.
Most people achieve that.
Oh, really?
Most people achieve that. If this had been the 1300s or something like that, then that wouldn't be true.
Yeah. Yeah.
I don't know what the percentage is, but it was a very high percentage did not live to adulthood.
63%.
You're just making that up.
Okay.
94% of all statistics are made up. I just made that one up too.
Do you know 100% of people who breathe die?
That's the one I always usually say. All right, ready? Okay, we're gonna do a process. I'm not saying the process is quick, it's not. There's 3 problems. Probably you'll figure it out after 2. I'm giving you a third for a bonus, right? You do have to do the third one, but I'm saying that these are not 5-minute problems. These are, for some of you, it could be a 10-minute problem, right? All right, so we were doing rotations of axes, and the reason we were doing this is because we don't have any formulas for conic sections that have been turned. We do have one formula. This was how it was introduced to you. The one formula for all conic sections can be written like this. It's got a lot to it. And then one of the skills, the first thing we did was we figured out what shape is it based upon that equation. Remember, we do have those specific equations for the specific shapes. But now we have one equation that describes all of them, except that we gotta figure out what the shape is. And so if I were to give you these right here, and the ones that, all those are centered at 0, 0, and the ones that are not centered at 0, 0, then there's double these formulas. I said the only one you're responsible for the non-0, 0 is the parabola. All right, so this particular one comes in 2 flavors. Flavor number 1, where B does not equal 0 or B equals 0. Those are the 2 flavors. And if B equals 0, then the B term just completely goes away. And we have these 3, I'll give it to you, formulas right here that tell you which shape it is, either parabola or ellipse or hyperbola. This was your homework, yes? Right? Pretty quick and easy when B equals 0. You just do A times C to see if it's 0, negative, or 0, positive, or negative. Very quickly done. For example, look, no B term. The B term has an X times a B term has an X times the Y. So if it's missing a B term, look, it's missing the B term right here. We simply multiply A times B, which gives us 18. And then we just say, is 18 0, negative, or positive? If it's positive, it makes an ellipse. And that's how quickly this is done. That was your homework, or half of your homework, right? The easy part. We will use that in the big picture today. What is the basic shape? Okay. Yes, I'm showing you all the details. Usually you can do at least this one in your head. Because remember, we're figuring out whether it's 0, positive, or negative. I don't really care that the answer is 18. I care whether it's 0, positive, or negative. All right. Very complicated way to do an easy thing. All right. When B does not equal 0, I mean, you're going to have a B term. We get a different set of formulas, 3 more. Well, we still have an A and C, but we also have a B squared minus 4 times AC. 0 stays 0 for parabola, but the ellipse and the hyperbola flip-flop. And it's because of this negative 4. If A times C is positive, you multiply by a negative, it's still an ellipse, and you get a negative, which is why the inequality for ellipse and hyperbola just flip-flop. Okay. So here's one where I have a B term. Look, it's negative 12. I got to do the math, unfortunately. I got to do B squared, so negative 12 squared minus 4 times 8 times 17. If I do all that math, I don't care what the number is. I just care whether it's positive, negative, or 0. We get negative 400, and we simply say, we got a negative number, makes an ellipse. Now, I did that very quickly. That was the same slides I showed you on Friday. Yes? Okay. It was the second thing that was the most complicated thing on Friday, and it was the last concept we did, and it was this. If I have a parabola, ellipse, or hyperbola, centered at 0, 0, but twisted or turned, how do you find the vertex, the foci, the axis of symmetry, the asymptotes for hyperbolas? How do you find all that stuff, right? What happens when we rotate them, right? And the question tonight for homework will be the ultimate question. What are these things? It's going to ask you all the details depending on what the shape is. But you're going to do this by using what we call a math trick. And the math trick is we lift the twisted shape up and we place it so that it is either up and down or left and right. So we reorient it. And if it's reoriented and still maintains the same proportions, then now we can figure out where those particular features are. Where are the foci? Where are the vertices? Where, in this case, the x-intercepts. So big picture, I'm going to take blue, turn it into red, and then take the formula for red and state where those major features are located. Get the big picture? Okay. All right. All of this will be done algebraically. None of it will be graphed. All right. In order to do that, write this down, box 1. We start off with the derotation formula. I take the formula that I'm given, the one that where the shape has been rotated, and I apply the derotation formula. Same thing we did on Friday. Unfortunately, the derotation formula has inside of it theta, which means it's an angle. On Friday, I gave you the angle. Today, I don't. And there will be a formula for it. Yeah. Dash is a tick mark. And in math, sometimes when I have two Evelyns in class, in math, you have two X's, but they represent two completely different things. We use a tick mark to delineate the thing from thing 1 and thing 2. So if I had two Evelyns, I could call the first one Evelyn and call the second one Evelyn prime or Evelyn tick mark. In calculus next year, if you take calculus, they will use this tick mark quite frequently. Which is why in pre-calc you get to see it for the first time. All it means is this X is different from this X. This is, we say X prime, and this is X. Or X tick mark. Nobody says X tick mark, but that's what it looks like. They say X prime, Y prime. If there's two tick marks, we would say X double prime. If there's three tick marks, we say X triple prime. And next year in calculus, you will see X triple prime and X double prime and X prime. You know, Caleb, 10th grader, or sorry, 11th grader Caleb, he's trying to teach himself calculus right now. So he got a calculus book and he's like, I want to learn calculus. I'm like, well, who am I to stop him? I'm like, go for it. So every day he comes in to either myself or Miss Newburn and says, what does this mean? And the other day he was doing tick mark things. I was like, oh, that's just called prime notation. And now I was like, oh, this is easy. He's taking algebra 2.
So he's skipping pre-calculus.
He says, I just want to learn calculus. I'm like, oh, all right. You're going to have problems when you get to trig because you won't understand the trig part of calculus, but you can certainly learn the algebra part of it without taking pre-calc. Okay. All right. So here was the example. It's the same one I did on Friday. I'm going to do this very quickly. We'll do the ones, like the big picture ones, very slowly together. So here is, if we were to graph this on a graphing calculator, we get to that shape right there.
Here's why it's wrong. It says 6. We're on 2.
I think it's because I copied from Friday's class, right? This shouldn't even have this box right here, right? Okay, we take this, we derotate it, we turn it into a known quantity, and well, I told you on Friday this one had been rotated 45 degrees, and you all said, how do you know it's been turned? And that's what we got to answer today. If you are not told how many degrees, we got to figure out how many degrees. Once it's determined how many it's been rotated, then we apply the derotation formula. So the derotation formula looks like this, right? That's for your X value, that's for your new Y value. And I simply plug in the given information. I don't plug in anything for X prime or Y prime, but I do plug in the angle for the theta value. And the theta value is 45 degrees. Cool. Unit circles tells us that 45 degrees is root 2 over 2. I can factor out a root 2 over 2 in this factoring thing tonight for homework when you're sitting there all by yourself. I would absolutely factor out whatever you can. It makes the algebra a little bit easier. That's what my new X is. It's been derotated. I do the same thing for Y. I plug in 45. It's still root 2 over 2. I factor out a root 2 over 2 and I get my new Y value. So now I have my new X value and I have my new Y value that have been derotated. I've taken that hyperbola and I've derotated it 45 degrees. Now here comes the hard part. I go back to this green, this original equation, and I replace X with what I just found out, this X right here. And I replace Y with what I just found out right here, that new Y value. So my new X value is this, and my new Y value is this. And according to the equation, what do I gotta do? According to the equation, I gotta multiply the two together. Going home? Okay. So I gotta multiply those together. So I squeeze those two together and I multiply them. What's root 2 over 2 times root 2 over 2? But root 4 is, and 2 over 4 is 1/2. Now notice I still kept that 0 there. Now I gotta multiply the x prime minus y prime times x prime plus y prime. Are you guys stacking or are you distributed properly? Okay, if I stack those two, I'm just doing the scratch work. I'm sorry, Winter, you can't see this. X prime minus y prime times x prime plus y prime. And then we should, oops. Then we just do normal multiplication. Y prime times y prime. Y prime squared. Y prime squared. Y prime times x prime would be x prime y prime. X prime times negative y prime would be minus x prime y prime. And x prime times x prime would be x squared prime. If we add, the middle terms go away, and we're left with that. Okay? And don't forget the equals 1, so it equals 1. Distribute the half to the inside, and now it looks like something we're familiar with. And so there's our, what? Hyperbola, because of the minus sign. There's our hyperbola. There's my A value. There's my B value. You could analyze this, and that's what we're going to do big picture. Hey, this is as easy as an equation as you get. It's just x times y. You can imagine that this could be way more complicated tonight for homework. It's going to be way more complicated. Complicated doesn't mean harder. It just means more work. It means more algebra. So today I'm going to focus on the algebra to make sure you got that down. Because the actual what do you do is straightforward and easy. This was as easy as it gets. It's just x times y. They can get much more complicated. The but here is also, I still haven't shown you how to calculate the angle, right? So let's do that first. So implies you know the rotation for that one. So let's figure out, well, how do you determine that rotation? So how do I know that this red one compared to the blue one has been rotated 45 degrees? Well, we get a formula, right? So we're going to crank up the difficulty. It adds an additional formula, right? It ain't that bad, the formula itself. In fact, it's a pretty simple formula. So let's add a challenging original formula for figuring out the angle of rotation. All right. Here's the first one we're going to do. I'm going to give you remember this is the one formula for all three shapes, right? This is a specific shape. We can do b squared minus 4ac, figure out what it is, and we will. But the first thing you do is you got to figure out the rotation of this, right? It's some shape that's been rotated, right? How much it's been rotated. All right. Big picture, you're going to be given that really ugly equation. You're going to figure out how many degrees it's been rotated, and then you're going to take that, plug it back in that previous step that we did right there, right? Remember, we took the original equation with the new x and the new y. We did a bunch of algebra, except it's going to be a lot of algebra. It's going to be a lot. It's not going to be just x times y. It's going to be a lot of algebra. But we're going to turn this eventually into this. And then we're going to take this and we're going to analyze it. What's the shape? Hey, what's the shape? Look at it. What's the shape?
The long ways.
It's an ellipse facing which way? Up and down is the long ways. Could you figure out from your sheet of data where you wrote this down, could you figure out what the foci, the vertices, and the x-intercepts? Could you do that? Yeah, using that formula. So you're going to turn that ugly thing into a recognizable formula that you can easily give me that information. Where are the vertices, where are the foci, where are the intercepts, that sort of thing. So that's big picture what we're going to do. We're missing that formula, so let's talk about that formula. So like I said before, there's occasionally times when I don't prove it. This is one of those times because I know kids struggle on the algebra and nobody struggles on the proof, right? So if you don't believe me, you can look at the proof on page 689. So here is the formula. So if you have that one formula for all conics, this one right here, and B doesn't equal 0, which tells you, guess what, everyone tonight will be a B does not equal 0, meaning you're going to have an X and a Y, then this formula determines the angle. COT means cotangent, so Seth is lucky. The rest of us got to deal with the fact that it says cotangent, not tangent.
Does that mean it's 0 is less than?
It means that 2 theta is somewhere between 0 and 180 degrees. Remember, both cotangent and tangent have vertical asymptotes. So therefore, we can't say it's going to be somewhere between 0 and 360 because you run into asymptotes. Pretty simple, straightforward formula, A minus C over B, where A, B, and C are simply the coefficients of the terms of our one formula. So that part is straightforward. We do have to deal with cotangent. We'll deal with it our normal way, except for Seth. And then, by the way, that's not what theta is. That's what 2 theta is. So the very last step is we'll be dividing by 2 to figure out what theta is. It's not that this is that bad or even that complicated, but it's just an extra step that's added in the process. How much has the shape been rotated? All right, got the formula written down? So now we have in box 1 the formula for the new X and new Y, and then we have this formula. That's all I need, along with all the stuff from the previous classes of if it's a parabola, ellipse, or hyperbola, how do I find those vertices and the foci? Okay, so we're going to put it all together. If you need to write this down, write this down. These are just the steps. Tonight for homework, it's going to say analyze the conic. So the steps are step 1, you got to find the angle using the formula you just wrote down in box 3. Step 2, this is the one that will take the longest time. There's a whole lot of algebra in this step. You do the algebra. You replace all the X's and all the Y's with that derotation formula data. And then the last thing, once that's all done, you turn it into a recognizable shape, a recognizable formula. Then you use the A, the B, and the C values of that recognizable formula to answer questions like, what are the key points? Where's the foci? Where's the vertices? Where's the x-intercepts, the y-intercepts? Where's the transverse axis? All that jazz. So it will require you to look back through your notes to all the previous lessons in this chapter in order to figure out, well, which ones, because most people don't have these values memorized. What's always A, what's B? Some people will, but most of us don't. Test is on Friday.
If it's not something, 11th graders.
Yeah.
We have a field trip.
So that means Monday.
Monday.
Yeah.
How about for everybody?
I have 2 pre-calc classes. We're taking the test on Friday.
But some of them won't be there.
And those are all 10th graders.
10th graders are going to be. Nicholson's taking the 10th.
I did not know that. Maybe I will give that a thought.
Maybe it should be a yes.
Maybe I'll give that a thought. All right. I thought it was just 11th graders.
Everybody will be gone.
Sweet. I should take the day off and play golf. I mean, I should. What day is this? Probably when it's going to be horrible.
Yeah, you already said we can't.
Maybe you can take us on a field trip.
The high is like 39 and it's supposed to be ugly weather. Right.
Yeah, let's go to softball.
Yeah.
Actually,
And then we can use Craig to determine the angle.
All right, here we go. Let's see. It is roughly 5 after, so I got 30 minutes to do two problems, and you're going to see how long this takes. All right. Here we go. Now, some people, because they're just so curious, will want to identify the shape. Okay, so you can use your formulas to identify the shape. I just say wait till it's transformed, and then because you'll be able to see it's going to be one of those recognizable ones. But you certainly could figure out what the shape is from the start. Okay. Step number 1 is find the angle. So I need A, B, and C. What are A, B, and C?
So A is x squared.
No, it's the coefficient.
A is 1.
1
B is 3.
root 3 and C is 2. And what was the formula?
A minus C over B.
So what is this going to say?
one minus two.
over root 3. Okay, that's pretty straightforward and simple. I didn't say it was a complicated formula. Okay, cool. 1 minus 2 is, and then I got to take the cotangent, right? How do I get rid of the word cotangent? How do I get rid of the word?
Inverse.
Inverse cotangent. Inverse cotangent gets rid of the word cotangent, but on the other side, yuck, I got to take the inverse cotangent, which is fine for Seth. Seth could type that into a calculator right now, put it in degrees. He could type that into his You got a calculator? Oh. He could type that in his calculator right now. The rest of us don't have cotangent buttons, so what are we going to do? No, it's just one extra step. What are we going to do?
Is it 1/10?
Oh, yes.
It is, but all that's simply going to do is take this and
Flip it.
flip it. So instead of being -1 over root 3, it's now going to be root 3 over -1, and that's what we're going to take the inverse tangent of, right? Because the relationship between cotangent and tangent is the reciprocals of one another, right? Okay, cool. So let's just do that. Who's got a calculator in degrees? Type it in and tell me what we get. Make sure it's in degrees, otherwise it'll be in radians, and we won't know what the angle is. We won't recognize the angle. How about that?
Tan.
Inverse tan root 3 over -1, or just negative root 3. How about that?
Negative.
So she got the answer -60. Yes? What's the problem with that? What's the problem with -60? What was the restriction in the formula? 0 to 180. So if I were to draw this out, we just figured out that we're 60 degrees right here.
Well, it's tangent, so just do a diagonal angle.
So what's that angle now?
120.
120, right? If this is 60, then that's 60. Therefore, from here to here would be 120.
Do you subtract 180 from 60?
Other way around, but yes. Subtract 60 from 180.
The 180 minus 60.
Yes.
There you go. That's what I meant.
I know what you meant. I'm just saying it more precisely.
Don't divide it by 2 when you.
Oh, yes. Oh, yes. So we just found out that -60, according to our restrictions, is actually 120, right? And then we have to divide by 2, so theta is 60 degrees. Yay us. Question?
No.
Because look at your formula. The formula doesn't say theta, it says 2 theta. So that 2 is still hanging there. We need theta for our derotation formula, so we got to divide by 2. Okay?
Wow.
Okay. We have now finished the quickest step. The longest step is step 2. Oh, wait till this. You can,
Yeah.
everyone is allowed to whine one time. All right. Step 2, the derotation formula. The derotation formula starts off with that, yes, for box 1. Except we're going to plug in 60 degrees. All right, grab your unit circles or the back of your book. Cosine of 60 is?
Pi over 3.
No.
Pi over root 2. Oh, you wanted to know that.
I want the actual values.
Oh, root 2, comma.
No.
Root 3 over 2.
One of them is, which one? Sine or cosine?
Sine. Cosine.
No, it is sine. Which would mean cosine is 1/2. All right, so there I did all that work for you, but remember, you would be doing this, so we're already skipping some time here. Hey, do these terms have anything in common?
The half.
The half. So I'm gonna remember I said factor out if you can. I'm gonna factor a half out of both terms. So if I factor a half, and trust me, this is a good step, it will make the algebra easier. So I factored a half out of both terms, yes? So there we go. That's not the answer, that's just the first part of step 2. First part of step 2 is figuring out what your derotation x and y are. I figured out what my derotation x and y are. The longest step of step 2 is the next one, which means now I have to.
Wait, now you have to calm down and wait 1 second before you do anything.
I haven't done anything ish.
No, because I need to write that down and then I'll listen.
We'll write it down. Let's talk more writing.
you know, everybody's all like, your senior year is so fun. It's gonna be so easy. You're just gonna do nothing at all. This
Who
is
said that?
Literally everybody.
Okay, now you-
Literally everyone who doesn't go to this school.
There you go. All right. So here we go. So we have that written down. Now comes the longest part. I'm going to do each one very slowly, right? The second example I do, I'll probably have to speed it up. All right. So here we go. I'm going to go back to the original formula, and everywhere I see an X, I'm going to write that ugly mess. Everywhere I see a Y, I'm going to write that ugly mess. So I'm going to do it all for you, right?
No, you're-
I'm going to take that right there, and everywhere I see an X, I'm going to write what's in the red box. And everywhere I see a Y, I'm going to write what's in the second red box. So this is going to take some work. It's going to take some work and some effort. Okay. So I just did it for you. Now I'm going to now show you why each one of these parts equals that. Okay. If I go from left to right, what's the first thing I got to do? I'm up here. If I go from left to right, what's the first thing I got to do? X squared. So I'm going to take this and square it. So I'm going to take this and square it. Winter, you can't see this. I'm squaring the red box. So it says the red box is 1/2 times x prime minus root 3 y prime. Yes?
Where would be good at 4?
I'm going to show you where each one of these numbers comes from. Ready? Yes. All right. So the first step is square a half. That's where this 1/4 comes from. Got it? Now I need to square, well, parentheses. Now I got to square this binomial. So I'm going to stack them and we're going to square them. So that's x prime minus root 3 y prime times x prime minus root 3 y prime. Yeah? All right, here we go. Negative root 3 times negative root 3. Just a 3, a plus 3. Y prime times y prime squared. This times this would be negative root 3 x prime y prime. Yeah? See where I'm getting that from? And this times this, this times this would be also a negative root 3 x prime y prime. And lastly, this times this would be x prime squared. Now add. Well, x prime squared turns into x prime squared. How many of these do I have?
2.
That's where that negative 2 comes from. And then I have plus 3 y prime squared. You see where all those come through? And all of that's got to be multiplied by 1/4. Got that one? What?
Oh no, I'm stretching. Okay, how many are you gonna put on the test? How many? 0?
1.
0?
1.
0?
Might even be 2 if I make one of them easy. Okay. Middle one. The middle one, it says what? Root 3xy. So I got to take root 3 and multiply it by x, and x is that thing. So actually I need brackets. So the one is 1/4 times x prime minus root 3 y prime. Okay, close the parentheses. And then I got to multiply that times y, and y is 1/2 times root 3 x prime plus y prime.
Wait, where'd you get 1/4 from? Hold on. 1,
I squared a half. That's where my 1/4 came from.
no, for the one that you wrote by hand. You did root 3 multiplied by 1.
That's a mistake. Good catch. It's a
Plus
half.
1.
It's a half.
I love this one.
Sure. Okay. Hey, what's a half times a half? Times root 3. See where my root 3/4 came from? Okay. So now I have root 3/4 on the outside. Now I got to multiply this times this. Okay. So I got x prime minus root 3 y prime times root 3 x prime plus y prime.
No, hold on. So did you do root 3/4 already?
What's a half times a half?
1/4.
Times root 3/4. Now I'm going to multiply this. Okay. This times this would be negative root 3 y prime squared. This times this would be x prime y prime. This times this would be negative 3x prime y prime. And this times this would be root 3x prime squared. So there's my root 3x prime squared. Negative 3 plus 1. There's my negative 2x prime y prime. And this one's all by itself. Okay?
Now I wish I dropped out.
No. No. Doing challenging things makes you better. The last one is we got to do 2y squared. So I do a 2 times y, which is 1/2, parentheses, root 3 x prime plus y prime. And I got to square that. Okay? 1/2 squared is 1/4 times 2. 1/2, 2/4, or 1/2. That's where my half comes from, right here. Okay, so that one's done. Now I got to square this one. So let's see. Root 3 squared is 3, so I get 3x prime squared. If I multiply these two together and then double them, right, that would be plus 2 root 3 x prime y prime, and that squared would be plus y prime squared. And that's what I have written right there. Okay, I know I did that one really quickly, but you get the process. No lie, this is a lot of algebra. And we still have this big hot mess that we got to deal with. It will eventually turn really sweet. We ain't there yet. Ish, we good?
No, hold on. Wait, so.
1/2 squared is a 4th,
Yeah.
times 2 is 2/4, which is a half. And then root 3x prime plus y prime squared is what's inside these parentheses right here.
Also, did you just move something else?
I did. And notice, I also moved this minus 10 to the other side. You'll see why at the very end. You didn't have to do it at this step. I just chose to do it this step. Okay, cool. So we got a big hot mess. Let's see if we can make it easier. Who likes fractions? So how are we going to get rid of these fractions?
Factor them out.
You can't factor them out because they're not all the same. Common denominator is, so multiply everything by 4. What's going to happen here?
1.
Goes away. What's going to happen here? What's going to happen here? What's going to happen here?
40. Where'd they go?
You just said the answer. You just told me that was the answer.
Oops, okay.
You literally said 1 root 3 240. Agreed. I told you. Unfortunately, now we need to
Rewrite it.
distribute. There's nothing to distribute for the first one, but for the second one, I'm distributing the root 3. But look, it's a good news story. Root 3 times root 3. 3. Root 3 times negative 2. What? Root 3 times negative 2.
Negative 2.
2 root 3. Okay, not a good news story. Root 3 times negative root 3. Negative 3. 2 times this.
Wait, so if you root it, okay, so is root 3 times root 3
Is 3.
it's 3?
And root 3 times negative root 3 is negative 3.
I thought it would be 6 though, because
3 times 3 is 9.
9, yeah.
Square root of 9 is 3.
Oh,
So this is going to give me a 6. This is going to give me a 4. And this is going to give me a 2y prime squared. See everything that I just did. All I did was distribute the root 3 and the 2.
I'm running out of space.
You're absolutely going to run out of space if you wrote really large like Ish did.
I'm trying to write small.
But guess what happens next step? It's going to get tiny. It's going to get tiny. Right? I'm going to go from left to right. I'm going to go from left to right. The first thing I see is, how many x prime squares do I have? 1. But I have, so I have a total of 4. But now I have a total of 10. So 1 plus 3 is 4, plus 6 is 10. Welcome to kindergarten. Right? Hey, let's do the ugly one, the x prime, y prime. How many do I have? Negative 2 root 3. How many do I have now? Negative 4 root 3. How many do I have now?
Root 3.
Oh, no, it just goes away. Look,
That's gay.
no,
No.
that was inappropriate.
Sorry,
Negative
I'm so sorry.
2 root 3 and another negative 2 root 3 would be negative 4 root 3 plus a 4 root 3 is 0. The x prime y prime
No.
goes away. How about the y prime squares? 3. No, that would be 0. 2 minus 2 is 0. 3 minus 3 is 0. 0, but then we're left with. So all of that turns to this. I told you eventually it would turn sweet.
So there's not an easy way to do this.
Nope.
Well, then we shouldn't be learning it.
All right, guess what the last step is? Everything by 40.
Why?
Because in a recognizable formula, guess what this number always was?
Oh, 1.
It was 1. So if I divide everything by 40, we get to recognizable shape. Hey, what's the
All of
shape?
that.
A
Just
long
for
boy's
that.
ellipse.
It's an up and down ellipse, right? So all of this to get to that. And by the way, this is the only way it can be done. There are no formulas for a rotated ellipse. There's a formula for up and down and left and right.
This is you. Yeah, this is disgusting.
Okay. Feel like we're done? You're done with step 2. All right, the rest is really simple. Step 3 just says, tell me everything you know about that shape. So I need to go back to my formulas that look like this, and I simply now quickly get to the answers. All right, which value is A, B, or C? A is not 20. A is not 4.
Oh, it's 5. 5.
Closer.
10.
Is this A or A squared? So what's A? 2 root 5. So if A is 2 root 5, I go to this picture where you find A,
Up and down.
the vertices. And it says the vertice is at 0A. So the vertice is at 0, 2 root 5, and okay. What's the other letter you recognize up here?
B.
What's B?
2.
B is 2. Where's B on this?
The covers.
Co-vertices, or in this case, the x-intercepts. Either one would be fine. So that would be at B0. In other words, 2, 0, and negative 2. So see how quickly that was done? The last step is done quickly. C is always the problem child because there is no A, there is no C here, but there is an A and a B. So you throw it into this formula and solve for C. There's my A squared, B squared. Add C squared, subtract 4.
4.
She's giving the final answer. Add C squared and subtract 4, and it would say C squared, add C squared, and then subtract 4. C squared would be equal to 16, right? Therefore, C is, okay, and C is the cosine. And it says 0C, so 0, 4, and 0, negative 4. That's how it's done. That's how it's done. Other than step 2, step 1 is, it's a pretty simple formula. A minus C over B. The last one is, you just figure out what A, B, and C is. With a picture of your shape, it's done very quickly. It's just step 2. That took me 20 minutes.
20?
We got 10 minutes left.
Okay, we don't even start it. Don't even start it. If you start it, then.
That's gonna be me tonight.
Yeah.
There's gonna be tears.
All right. All right. Okay, it is the longest procedure of the year, so but it's just algebra. It's not, there's no thinking like in terms of like, I don't know what to do. It's just algebra. Okay. By the way, picture form, red is the original equation, blue is the one that we just did after we derotated it. It's the same shape. All right. How about you watch me do one, the last one, just so you have the steps down in your head. Okay. All right, so here we go. You're going to be given the big ugly formula. The first thing you do is you figure out the angle. The angle is A minus C over B. So in this case, that's 5 minus, well, that gives me 0. Okay, it's 0, it's fine, right? Now I got to do the inverse cotangent of both sides. Well, 0 is 0 over 1.
45.
But the problem with flipping this, his calculator is going to be perfectly happy with this. we're gonna have to do the inverse tangent of 1/0, and we're gonna get error. So where is tangent
Oh,
undefined?
90,
90 degrees and 270, well done. So we know that inverse tangent is not defined at 90 degrees. It's the only place it's not defined. So if you ever get a 0 on the top, then you know you're at 90 degrees. Because remember, our formula says you're between 0 and 180 degrees. So I know I'm at 90 degrees, right? The problem is I can't type that into my calc. It'll say error.
If it's a 0 on top, it's.
If it's a 0 on top, it's 90 degrees, 100%. Okay? So we know it's 90 degrees and half of 90 is. There we go. So that's done pretty quickly, especially with a calculator. If it's not the 90 is the only one you got to think about. Okay, cool. Now I'm going to plug in that to my formula, 45 degrees. We already know that sine cosine at 45 degrees is the thing you were trying to say from the start.
Oh, root 2.
Root 2/2. Okay, so all of that's root 2/2, and we've seen this before. We factor out the root 2/2, and we get this. I'm clicking this very quickly, but we've done this one before the previous one. Okay, so there's my new x and there's my new y. What do I do with those? Left to right, and I do the algebra. Okay, pick one. We'll do it together. You want to do the x squared, the xy, or the y squared?
The one that has X and Y together.
So I'm gonna just show you. I'll show you the entire answer, but we'll do the middle one together. Okay. So I need to take 6 on the outside, and then we need to multiply x times y. X is root 2/2 times x prime minus y prime, and I need to multiply that by the y. The y is root 2/2 times x prime plus y prime. Okay, got that? Root 2/2 times root 2/2
1/2.
times 6. There's your 3. Yeah. Multiply this times this. Hey, look, one's plus and one's minus. You chose the easy one to do. One's plus and one's minus. So that's just x prime squared minus y prime squared. Because positive times a negative is a negative.
When you stack them up on each other, is it just like normal?
Yep. Just normal multiplication algorithm. Okay. So that's where the 6 comes from. Okay. All right. The 10/4 came from when you multiply 5, right? Once you square this, right? That's where that comes from. Okay, cool. So we good for the rest of this?
Yeah.
Okay, what will be the next? Oh, by the way, I moved the 8 to the other side. Now what? Get rid of the fractions. Everything times. So that's going to be 10, 12, and
Wait,
because 3 times 4 is 12. Yeah. Yes? Now, unfortunately, now once you get rid of the fractions, you distribute. So that's going to be 10, negative 20, 10, 12, negative 12, 10, 20, 10. Now comes the magic. Just go from left to right, count x squares. So I got 10 of them. I got 22 of them. I got 32 of them.
32.
Yes, every single time the x and the y are going to go away. Just to show you, negative 20, nothing. Positive 20, poof, goes away. We got 10, we got negative 2, we got
I'll divide by 32.
x squared over 1 plus
1/8.
1/4 and a 1. Yeah? There's your step 2, done. Step 3 is we take this and we analyze what's the shape. It's the same one again, right? The same one again, right? So it's an up and down one. All right. What's the a value? 2. And the a value is your vertices. So your vertices are at 0, 2, and 0, negative 2. See how quickly that was done? Our b value is 1, and b is the co-vertices, or in this case, the x-intercept. If this is spaced that way, then it's the y-intercepts. So negative 1, 0, and 1, 0. Okay. Lastly, to find the c, we got to use this formula.
Can we just put plus or minus 1, 0?
You could. Right? We plug in those values, subtract 4, you get negative 3, so we get the square root of 3. And that's going to be your foci, so your foci are at full point.
Root 3.
0, root 3, and 0, negative root 3. There you go. That's the whole process. Okay, so I did that one in 5 minutes, but I talked you through the whole thing. The hardest step, and I'll go back to it, is this right here. This represents this. And by the way, this or the first step down here, I mean, I'm not even showing you all the details because I don't have enough space to show you those details. So when you're doing that x squared or the x times y, I always use scratch work off to the side to do that. Hey, if you get to this step right here, I'm sorry, right here, and you're right here, and when you do this, you wind up with an x and a y, right? X prime, y prime, you've done something wrong. The x prime and the y prime, those terms should cancel out. Always when you do this. That's how it turns into a recognizable shape like this. So it will tell you you've done something wrong when you get to that step and you wind up, wait, I'm still left with an x, then you got a mistake somewhere. This is just an algebra problem. This isn't a truly, we've done way more harder things in trig than this, having to think about the problem. This is just an algebra thing. And to answer your ultimate question is, could you write a computer to do this? 100%. Our calculators don't have this feature. I mean, if it's just algebra, any computer could do that. Cool? All right. So I was not able to make it through this. First class, I was able to make it through both examples. But and just so you know, green was the original shape, blue was the final shape.
Is it only one?
No, it could be any one of the shapes. Right? Homework instructions 33, ignore what it says in the book, do exactly what we just did. So what did we do? We just do that procedure. Identify the angle, apply the V rotation formula, and then you analyze the shape.
So don't graph it.
You do not have to graph it, no. If you're curious, and by the way, none of you have a calculator. Oh, I think Seth might. I don't remember. I think Seth still has to have a y equals, yes, on your calculator? I don't remember. Yours will say f of x, but yeah. You could use this is done in Desmos right here, but Desmos, you never have to solve for y. This would be challenging to do on your TI-84. All right, that's it. That's the whole class with 2 minutes to go.